All right, ladies and gentlemen, good evening. I don't know if you guys are here or not. We will check you out late if you are here. Let's see, where are we? There we are. We need my magical pen. Where did I put it? Great. So um, we are live. I don't know if you can see me. I'm trying to find out if I can see myself actually. Right. Does it say that I'm videos home? Hopefully it shows that I'm live. Yep, it says there I'm live. Let's see, let me turn this off so we don't have two mics. Right. Oh, oh boy. Let's see. Okay, great. Let me take the volume here. Okay, can you see me? Can you hear me? Can you hear me is the question, right? Can you hear? I can't type that fast. Can you hear me? All right, so we have some questions here. Let me go to a page. I don't even know what's next, what's next. These are all the exercises that I have done. Some of them I haven't done. So, create previews. Hello. And perfect. I'm Omar, by the way. Mr. Omar. Hello, Mr. Omar Sharif. All right, guys, I'm here to help you. You have to let me know if there's a particular question that you want, and I will write it down, and then we'll go back and try to do it together, right? So we're ready. I'm here. I'm not going to teach you anything unless you have a question, a specific question. I hope you study. I hope you go to bed not too late today, and you are restful and peaceful for tomorrow. So, okay, I am here. I see some of you are here, so I'm waiting. I'm just going to be waiting for questions. All right. I'm not sure when we're going to keep this video because it's just going to be me talking. All right. I'm looking at the screen to see if any questions have come up. No questions. Okay, I see 7 people are watching me. That's good. But remember, it's not to watch, it's to ask questions. You have to ask questions. Look at your exam, final exam. At this point, you should be concentrating on your final exam. The final exam, for some of you who are curious, final exam is tomorrow. All right. And it has part 1, has 5 questions. And part 2 also have 5 questions. This one has a lot of pages because it's a lot of, it gives you a lot of space for this. So this part has a lot of pages, and this one has, I think it has 9 pages long, and this one has 8 pages long. Okay, let's see. Jefferson, Mr. Jefferson, good evening. Hi, Mr. I would like to ask you help with question number 31. So let's go back to question 31. That's 34. That's 31. And let's make it a little bit bigger. Okay. Question 31. So make sure that you are with me if you haven't done it yet, right? I probably going to ask you some help because my calculator doesn't have some, um, right, some keys. So let's take a look at this. It says at the Forest State Bank, the average savings account in 2012 was 1,300. So they right there they're giving you um, one important piece of information. The other piece of information that you should know is that the average savings account balance. So it doesn't talk about a sample; it talks about the whole population for this bank. So we are going to declare that mu, which is the average balance for 2012, is 1,000. Sorry, 300. Okay, a random sample of 45. So this is, we should say that whatever I'm going to write here is from the population, and whatever I'm going to write here is from the sample, right? So a random sample of 45 savings, 45, sorry, I wrote 5 without the 4. 45 savings account balance for 2013. This is for the sample. This is for the year 2013. This is for the year 2012. Yields a mean. So this mean is the mean for the sample 1,350. With a standard deviation, this is a standard deviation from the sample of 80. Okay, and now we have some information here which tells me that the significant level is 0.1. Can we conclude that the mean savings account balance, this conclusion is going to be in a comparison between what you had in the population and in the sample. So, can we conclude that the mean savings account balance is in 2003 is different? Okay, we use the word different in the class, and we identified this word, I'm sorry, with a hypothesis testing, right? Hypothesis testing. And if you remember, when they use the word different, they're using this symbol, different, hypothesis testing. So now here we're going to write our information for hypothesis testing based on what we have here. H of 0 is always using the equality, and H of 1 or H of A is the using some inequality. In this case, because of the word different, they're using this inequality, and this is going to be the number 1,300, and we use the same number, 1,300. So the question is, based on this sample, can we conclude now that the average has increased or is different than 1,000? Actually, it doesn't say to increase, it's just it's different than 1,300. So this is the information. Because they're using this symbol, this is a two-tail test, right? This symbol automatically declares that we're going to be looking at two tails. Okay, we lost some people there. Okay, so let's begin the question. Number one, we have to decide whether this is t-values or this is going to be z-values. Because they're giving me the standard deviation from the sample, we are assuming that we are going to be using t-values. T-value, that's what we're going to use. So we got to set up our example. We can do this in different ways. Okay, one of the ways that we can solve this problem, remember there are three ways to solve it. We can use the confidence interval. which is something that you are familiar, confidence interval. Okay. Okay, so to do the confidence interval, we're going to try to do it in a couple of different ways for you to review. Confidence interval is this interval, right? X minus E greater than mu greater than X plus E. We do have this information based on the sample 1,350. We need to subtract the number. We do have mu, it's 1,350, but we're going to write mu to make sure that if that number is in there, 1,300, I'm sorry, if it's in there or not, this is the same. And we're going to add E. Now, to find E, we need to find the error, right? So, what do we find the error here? Okay, the error will be a formula, which I hope you know the formula, right? Oh, I see it. There's another question there. Okay, let me finish with one question first, and then we'll go to the next one. This is we're using T alpha divided by 2, and we are going to multiply this times the standard deviation and the square root of n. So that is some of the things we're going to do. I don't know, some of you got a calculator. I don't know if my calculator is going to be able to do that. So let's see. Let me just check something in the previous page. Right, let me just see if I have that number so I don't have to do it in my calculator. I don't have it there. So let me see for the previous. No, I don't have that one there. I don't think I have. I didn't. I don't think I did any of those exercises. I think I did it online, but not here in this particular case. Okay, so we're gonna have to do it. Let's see if my calculator is gonna be able to do that. So we got to find this value. So let's go to the calculator. We have E here. We don't know that value. We know the standard deviation is 80. We know the square root of n, which is 45, right? And we now need to multiply it times that. So let's go to the calculator. Here's our calculator. Let me bring it to, actually, it's best if I bring it to here. So give me 1 second. Let me bring it here because I need to see the numbers. Okay. All right. So it tells me that the amount that they're using is 0.1. What does 0.1 mean? Because this is a two-tail, I'm going to bring that back. We have to have 0.1. So we need to have 0.1 divided into two pieces because it's two pieces that we need. So let's bring that again, which is 0.1, sorry, menu 1, 0.1 divided by 2, and that gives me that quantity, 0.05, so we're going to have 0.05 here, and we're also going to have 0.05 here. So together you got 10, and in the middle, even though they're not asking me, you're going to have 90, right? Because all three together have to be equal to 1. If they only have one side, then only two pieces will have equal to 1, but this is a two-tail test from the very beginning. It tells us so. So now we can calculate that. We're going to go to Z values in the calculator. We're going to the menu. We're going to go to number 2. We're going to go to distribution. T values. See, mine doesn't have the inverse of that. So it's if you can, I'll tell you what you need to do. You need to tell me. Anyone has a calculator? If you have a calculator, I'm going to tell you what to do because I need the number, right? Because my calculator doesn't have that. You need to go to distribution, you need to go to T, and in your calculator there will be another piece over here that says inverse. Inverse. So in that part of the calculator, okay, right? When you press that inverse, it's going to ask you for the area. The area is going to be 0.05, and it's going to ask you for the I believe it's going to ask you for the degree of freedom or some information, but you have it here, and you have the standard deviation also. So could anybody give me that inverse, right? Because I don't have that number, so I need it. Okay. Anybody is able to get it? I'm waiting for. Yep, 1.68 is correct. So we're going to be using 1.68. That's correct, 1.68. And now we need to multiply this. That I think we can do together. Thank you for the person, that was Mr. Omar. Give me that quantity. Let's go to one in menu and let's just do that, right? 1.68 times parentheses 80 divided by the square root of 45. Let's close that. And that's going to give me, did I do that right? That's going to give me 20.04. It's 20.04. So we're going to go 20.04, and then we're going to put 20.04. So we need to subtract those two numbers from there. Let's go back to the calculator. I hate to be able to do this all the time. Let's put the calculator here. And now we're going to do 1,350 minus 20.04. I'm reducing the numbers of the decimal because of simplicity. 1329.96, 1329.96, and now we need to add the number. Okay, so let's go back to that, and what do we get? 1,350 plus 20.04, and that gives me 1,370. 1,370 point, I think, what was it? 0.04. Okay, so question is mu of 1,300 in the interval? Well, the answer is no. So the conclusion is we reject H0. Okay, we reject H of 0. This is one way. This is one way to test this. I guess we need to. I don't know if you guys want me to do it in the other way, which is the what do you call the traditional method. I mean, I'm gonna wait for. Okay. To see if maybe we do it because it's I don't know what it's gonna be on the exam, but if you want me, can you do it in another method? Okay, sure. So let's solve it with another way. We will use the same piece of information. If, by the way, before we go to another method, is there any question with this one? Okay, while you are answering that, we are gonna go to another way, another method. We use a different color so we don't. We're gonna solve it using the traditional method, right? All right. So let's see the, oops, sorry, the traditional method um, uses some of the stuff that we already know, right? The traditional method, you compare, uh, ooh, sorry, that came out really bad. All right, in the traditional method, we're going to use the t-value, which is called the critical or the test statistic, which is based on the sample that we got, right? In the sample that we have um, the test statistics that we have to get. So we need to find these test statistics, which is a t-test statistics, and then we're also going to have it here. This is based on the t-value based on the sample, and we're going to compare that to the t-value that we already have, which is 168, right? 168 negative here and positive 168. So this is the t-value that we have base, I think where we get this, we did the inverse of 0.05. So now what we need to do is to do the test statistics based on this. Again, I don't have my calculator. I don't know if my calculator is going to be able to get this number. So it's I might have to use a table. Um, can anybody try to do this in the calculator? I'll show you what you need to do because I don't have right. Can I ask you, when you did the 168, whoever did the 168, what were the questions that they asked you to do the 1.68 in the calculator? Because I don't have one with me. I should have brought my own calculator, but I didn't bring it. So we have to wait for the calculator. But I actually have I have the answer to this. I have it, even though I don't have the calculator. I have the answer. It's this number is negative 4.19 and positive 4.19. Now, how do we get this? This is, remember, let me see if I can do it here without the calculator. The t-value, this value is gotten by taking the x bar minus mu over, this is always going to be done here. I mean, you can use it in the calculator, but I guess at this moment it's better to do it like that. Standard deviation over the square root of n. So we do have these values. Let me see, 1,350. Okay, 1,350 minus 1,300 divided by the standard deviation. What was the standard deviation? 80. 80 divided by the square root of 45, right? So if you find this in the calculator, all right, so this is best to do it by hand. I guess this would be done by hand. And this is the one used by the calculator. You need to get both, right? You need to compare both. So if we have a calculator on screen, let's bring it back. Okay, let me put it over here because I won't be able to see that. So let's do the top is 1,350 minus 1,300. That was easy. I didn't need to do all that. Okay, and that's going to be divided by 80 divided by the square root of 80. Okay, oh, square root of 45, sorry. Square root of 45. Let's do that. I have to add a parenthesis here. Otherwise, it's not going to do it together. Let me add it. Shift, insert, parenthesis there. We didn't do the 1,350. Shift, insert. Okay, 1,350 minus 1,300. So that's a mistake. That needs to be corrected. Not the 300, and now we're going to shift, insert that, and put a parenthesis there. It didn't work. Let's try one more time, and there you go. And that's going to give you 4.19. Okay, that gives me 4.19. I'm going to leave that on the screen for a second so that you can see what the number was, and it's 4.19, right? So this, I told you it's going to be 4.19. So now what we need to do is to bring these two together, right? To bring these two together, I hope you remember how we got this number, 1.68. We got it, remember, from the other number. If you doing this method, you just got it from, you don't need to insert it here because that's a different method. So now we're going to compare these two things, right? And we are going to compare the two of them. All right, the 168 is here, and the 168 is here. This is the one that tells me what's okay, not okay. This is not okay area. This is okay area. This is not okay area. Now let's bring the 419. 419 is here because it's before. And the 419 is here. So as you can see, it's a problem because the 419 is not okay. It's not okay, not okay here and here. So the conclusion of this is the same conclusion we have with the previous method. Any method will give you the same conclusion. You're not always going to reject H0, but in this case, we reject H0. Why? Because the statistic is inside of the yellow area, right? So it is not acceptable. We had a similar situation with the yellow where 1,300 was not in the interval and it's not here. Now, there is another method, which is the p-value. Okay, so what is the p-value? It's very simple. This is the last method. This is to solve using the p-value. So before I move on to the p-value method, I want to make sure that there's no questions for the one that I just finished. No, maybe I'll put it up again so that you can see it. Let's review it. I did this by hand. That's based on the sample. I did this by the calculator using the inverse to find the area. And then I compare the okay, not okay area, and I check where this test statistic is inside or outside of that. I see Emily Donite is there too. Okay, so let me wait for a moment and see if anybody else has a question with that. All right, if no one has a question, then let's move on to the p-value method. It's very similar to the one we just finished. We can use the information. Oops, sorry, that's not what I want. We want to make the normal curve. And that came out really bad. That's what happens when you don't know how to draw. So this is the normal curve. And the test statistic is what we use here. Remember that we got 4.19, and I keep doing it on both sizes because this is a two-tailed test. That was determined from the very beginning, two-tailed test. So it's two-tailed test. Now what we need to know is what is the area here, right? What is the area here? And again, I don't have that function in my calculator. You're going to have to find that area in your calculator. You need to find the area, and one thing you need to know is that the degree of freedom for this particular case would be 45, since n, which is 45, gives you the degree of freedom is 44. A p-value is the third method, so maybe I will put here third method. This is the method that it's used mostly in colleges now, so it's definitely going to be created, right? So, oh, maybe we can do this. Oh, I think we can do this with my calculator. Let me see. Hold on. Okay, let's go over here. I believe we can do that with my calculator. Let's go to menu. Oops, sorry, menu number 2. And we are going to go to distribution. This is a t-distribution. And I believe so. Lower will be a number that is, these are t-values, so the number here will be any number lower than 4.19. So let's go back over here. So a lower number could be a negative 100 if you want to. The upper case would be negative 4.19, negative 4.19. And the degree of freedom is 44, and that will give me a p-value, a very small p-value actually. It's 6.6064 raised to the power negative 5. So this area here is 6.6064 e to the negative 5, right? So what does that mean? 60.6064 times 10 to the negative 5. So we got to move the decimal point. Oh, maybe I shouldn't do it over here. Maybe I'll do it over here. 6.64, and we're going to move the decimal point 5 times. 1, 2, 3, 4. So it's 1, 2, 3, 4, 5. So it's a very small number, and I told you that the smallest number that we accept, the smallest number we accept is 0.0001. So if it is smaller than that, we just use this. So use this one, right? Now remember that area, which is now 0.0001, is also here because this is a two-tail. So now what we need to do is we need to add these two because there's two of them. So we're gonna have to say 2 times 0.0001 is equal to, because it's two tails, right? That's the number that we decide we're going to use, 0.0002. And now we are going to compare this with the original number that they gave us, which was the confidence level of 0.1, remember? Now this number is smaller than that number, so 0.0002 is smaller than 0.1, so we reject a 0. The only way not to reject 0 if this value, which is called the p-value, it's greater than. If it's greater than this number, we do not reject H0. But in this case, it's the opposite. So we reject, and our answer is consistent. The three methods gave us the same answer. Okay, again, my suggestion is to review this, the video a couple of times. You can do any of the three methods. It's acceptable. Okay. All right. I've seen before. I'm not sure. Let me go back a little bit, but I think we have seen some people wanted me to do question 31. Yeah, 31. What question? I did 31, so I said 33 is the other one. Okay. Okay. So Marianne as Gary asked me for 16. Okay. I'm gonna do 31. What happened is, Gary? You asking me? You want me? I saw you. You want me to do 16, but somebody had put 31 there first. So let 31. I believe 31 is very similar to this one. So let's check it out. This is 24. 31. What is 30? Why do I have that one? I don't know if I have 24. Oh, 31 it's in another video. So I'm only doing the ones that are not in the videos before. Let me see if 16 is here. Oh, 16 is here. Okay, so this is a long one. All right, let's see if we can do 16 then. Let's put this a little bit in a different position. Let's see if we can put this a little bit bigger. Jefferson, I think you were doing it right. We did 31. Yeah, we did 31. We did 31 in one of the videos. If you look at one of the videos, which I'm gonna, let me double check that we do have the 31. Follow me on the videos here. I know we are going back to this, but I'm gonna show you question 20, question 18, question 21. It's here. 21 is here. Let me see, 31 there. Final, this is final, has 30. Oh, maybe I don't have 31. Right. Oh, I guess I didn't have 31. You're right. I don't have 31. All right, so let's do 31 then, because I don't have 31. You're right. Okay. Just was not Jefferson. Oh, okay. We were just doing 31. So which is the one that you want me to do? 30. I'm a little confused now. Let me see. Which is the one that we just did? We're going back. So I'm not going in the wrong direction. We did. This is the one that we just did. And this was 31. So, do 33. Did I do 33 before? Let me see. 13, 11, 33 here. If you go to the final review, 33 is here. So I don't want to do that again because I did it already, and you can go watch the video. Just go to this area here where it says MIT 120 final review, question 14, 15, 32, and 33. I think it's the last one. So you can skip the video. So I just want to concentrate on the one that we have. Okay, so 33 is there. Mr. Jefferson is here. Yeah, I know I did 31 and 33 is here. So this is done already. I'm not going to do it again. Okay, so let's go to question 16 because that's another question popular with the people. I think at this moment, I think I did almost all of them. All right, let's go to 16. Uh, let's see. Shipment of television set arrive at a factory have varying levels of quality. In order to decide whether to accept a particular shipment, inspectors random select a sample of 10. So that's interesting information that we should be writing. N is equal to 10. Select a random sample of 10 television set and test them. If no more than one television set in the sample, if no more than one television set in the sample is defective, the shipment is accepted. So, okay, in the shipment, they're going to set no more than one. So, 0 and 1 is okay, they pass the shipment. Okay, if no more than one television set is in the sample is defective, the shipment is accepted. Okay, suppose a very large shipment arrives in which 2% of the television sets are defective. So a shipment where 2% of televisions of TVs are defective. Let X be a random variable representing the number of defective television in the sample set of 10. So X is number of defective TVs for N equals 10. Okay, so question A. Explain why X may be treated as binomial random variable. Well, if you can identify these 4 things, I'm sure that you can call this a binomial, right? Number 1, you have to have a fixed number of samples. Yes, you got 10, so that's okay. Specifying words, which event will be defined as success? Success, which is represented by the letter P, right? What is success? If we can say success, because remember, the second thing that you have to have for binomial distribution is 2 answers. One has to be yes and no, defective, not defective. So P is, we have it here, if you have 0 or 1 defectives, that is called okay. And if it's okay, but if it's not 0 and 1, then it's defective. So we are looking for defective ones. So this is going to be our P, and this is going to be our Q. Remember, one has to be defective and the other one has to be not defective. So this is not defective or defective, and we say it's okay. Not defective, okay. This is defective. So we're looking for the defective ones, and if we find the defective ones, well, then we find what we're looking for, and then we call that P. Okay, so explain why the trial must be considered independent. Okay, all right. If you find one TV that is defective, that doesn't mean that the next TV cannot be defective. If this is defective, for example, this can be defective too, or this can be defective or not. This could be defective or not. So each one of them is independent from the other one. So that's number 3. Number 4, give the value P, the probability of success. Well, they told us that the probability of success um, it's 2%, right? So the probability of success is 0.02 or 2%. It says 2% are defective, so P is that, so that's pretty good. And Q is the opposite, it's 1 minus 0.02, right? So that's going to be 0.98. Okay, so we have A all done. Let's go to B. Man, why normals are not P's? I'm not sure. Don't get it. All right. Which part you don't get? Gary and Sharif. You got to be a little bit more specific as to there are 4 conditions that have to be met, and the way that they ask you is that they help you asking each one of those things, conditions, they have to be done right. So the conditions are, if you remember what, conditions to use binomial probability, condition to be binomial probability is not fixed and has to be fixed. In other words, you can't change that number, fixed number. That's one. Number 2, you have to have 2 answers always. Yes or no. Your answers here is defective or not defective. That's the other condition. Number 3, each trial or each time you look at TV is independent, and we say that each TV can be defective or not defective. And the last thing that you have to have, these 4 conditions are important for binomial probability. And the other condition is the probabilities, all probabilities are constant. In other words, they don't change. If you look at TV, this TV can be defective. If it is defective, it's 0.02% probability of defective. And if it's not defective, then it's 0.98. Together, it gives you 1. You know? The next TV can have 0.02 or 0.98. So that's what he's saying. Okay. Oh, why defectives are P? Because this is what we are looking for. If you don't find the whole premise of the problem is to discover if a shipment is defective. So if you are able to find that the shipment is defective, then you found what you were looking for. It's just a matter of perception in this kind of problems. You know, the perception is that that's what you're looking for. You're looking for that particular thing. And also, another easy way to identify is that usually the percentage that is given is P. The percentage that is given is P. I would say 98% of the time when the problem talks about probability of something, that's P, and 2% is for defective TV. So that makes it a little bit easier knowing that 98% of the time when they give me in the problem, the given probability is for P. Okay. All right. What is the next? What is the probability that this shipment is acceptable? Use a table or a formula. Now, acceptable, it's let me use a different color. Acceptable is, let's see if it is x is equal to 1 or x is equal to, actually we start with 0 or 1, right? The problem said that it will be okay if you find 0 and 1. So what's about the shipment is accepted. So that's going to be my answer. What is accepted is 0 and 1. So I need to do the formula. Why am I allowed to use the formula? Because I checked the 4 conditions. And if you check, then you can use the formula. The formula is NCX P to the power X Q n minus x. So we are going to use the formula twice, right? And then we're going to use NCX PX QN minus x. For 0, it's going to be for 0, and it's going to be for 1, and then we're going to add them, and that's going to be the probability. Okay, somebody said that, Omar said that the n is not bigger than 30. We are not doing normal distribution. This is binomial distribution, right? Binomial distribution has a different set, it's a special type of distribution where 4 conditions are met. If those 4 conditions are met, then you can use binomial distribution. So, okay. If normal distribution is based on a sample that is equal to 30 and it has a different set of conditions. I don't know if you remember the type of conditions that we had for normal distribution. Normal distribution is talking about whether you have the standard deviation of the population or you have the standard deviation for the sample, or if n is equal to 30. I gave you a map of the different possibilities, but for this particular problem, we are not doing die type. Don't mix the distribution. You have uniform distribution, you have normal distribution, and you have binomial distribution. Those are the only 3 distributions that we have formulas for, and we have work. Okay? So if we use the formula, that would be n. What was n in this problem? 10, right? 10. C, in this case, x is 0. P is 0.02% to the power of 0. And Q is 0.98. 10 minus 0, that would be 10, plus, that would be 10 C1, 0.02 to the power of 1. 0.98 to the power 10 minus 1 is 9, and we add them. Okay, I don't know if you have calculated to add that. Okay, let's see if we can bring a calculator up. Okay, and let's put the calculator here. Let's go to menu and put this here so that we can see that number. We're going to go to 1, and we are going to go to this, and we are going to go to 10 first. Options, right? Remember options, and we're going to go to probability, which I believe is F3. F3 again, 10C0 times parentheses 0.02 raised to the 0 power. I didn't need to do that. Okay, I did it anyway. Times parentheses 0.98 close parentheses raised to the power of 10, and now we're going to go plus 10 C1 times parentheses 0.02 to the power of 1. We don't need to write that down. Parentheses 0.98 times, raised to the power of 9, and that will give me that much, which is the probability is 0.9838, 0.9838. This is a very high probability that the shipment will be accepted. So that's what we want in real life. We want, you know, we want the shipment of televisions to be accepted, not rejected. So if you find a one that is rejected, that's when, I know you will call that failure, but that's what we're looking for. We're looking to stop a shipment that is wrong. We don't want a shipment that is wrong to go into the store. So if we find it, we find success. Success in the sense that we're not selling television that are defective. That's basically okay. So that's A, B, and C. B, what is the expected value of the number of television set in the sample? So we are going to go a little bit down because I don't have more space here to do C. So we're going to go down here and maybe use a different color. What is the expected value, which is symbolized by the letter E? Which in reality, this means the mean. We're looking for the mean. Now, because this is binomial distribution or probability, whatever you want to call it, binomial distribution has a formula to find the mean. This is to find the mean. If you want to find the standard deviation of a binomial distribution is n times p times q, the square root of that. But they're not asking me for the standard deviation. They're only asking me for the binomial distribution. It's very simple to get the binomial distribution mean. It's n, which in this case was 10, and p, which is 0.02, which is 2% of 10. 2% of, which makes sense, it's 2% of 10. That's how you get the mean. At 2% of 2, right? It's 0.2. That is the mean, 0.2. That means that if you keep doing this, you keep doing many, many, many times, I would say 20%, that's 0.2, it will be the mean of the number of defective, but you're gonna have to do this over and over and over again to get that 0.2, which is very small. It's not. It's almost zero. It's almost zero. Not even one. So the number of defective ones is gonna be less than one. Basically, that's what it says. Very low percentage. That's why most of the time it's gonna be accepted. Okay. Let's see if we can fill out the blank on the last one, which I'm going to do over there. Okay, remember this formula you can only use if you have proven that this is a binomial distribution problem. And how did you know? You got to pass this fourth, unless they tell you it is a binomial distribution. If not, you will have to prove somehow in your head that this is 4 cases are correct. Most of the time, it's going to be able to use it. Okay. All right, so let's finish this. According to the law of large numbers, I mean, if you keep doing this over and over again, we have obtained many different random samples of size 10. They're all size 10. That's the idea, that they're all 10. From this shipment, the average number of defective television set will be approximately 0.2. If you keep doing that, this is the average. The average television, which is the expected value. Remember, this is what we call the expected value. This is another way to say expected value is the average. And we got the average down there with the formula 0.2. Okay, that's question number 16. All right, any other question, my friends? Okay, I'm trying to look at your okay. I think I did the ones that you asked me so far. 31 is already there. 30. 33 is already there. 31 is already there. 16 is there. Okay, it says 24. Let me see if 24. I haven't done 24. I don't know. Let's do 17, 18. That's 19. That's 22, 24. Okay, 24. I haven't done 24. I think like this time I'm almost did almost everything. Maybe like 3 questions I haven't done. All right, let's do 24. A study states that for a particular area, the average income per family is 34,469 and the standard deviation is 8,256. What percentage family in that area earn below that? Okay, that is a, we need a different color. You can't see that one. I'm going to do my studies say that for the average income per family and the standard deviation is what percentage are earned below 25,000. Now, this question doesn't really tell you if this is normal distribution or not. I don't have the heading. Usually, it tells you at the heading of each question whether they are in the normal distribution. I believe this question has a heading that says normal distribution. I didn't copy the heading. So if this is normal distribution, it will certainly apply the rules that we have. And even if we don't have normal distribution, we have what percentage of families. So we're dealing with the population here. A study states, yeah, it tells you study, and if you keep doing samples, you will get the central limit theorem going on here. But most likely, this is not going to happen in the final. They specifically will tell you if it is talking about normal distribution. It just this happens to be on that area of the exam. The average income per family is 34,569. So that's mu. And the standard deviation, which we're assuming is the population, is 8,256. What percentage of families in that area earn below 25,000? So 25,000 is a number that is on the left side of the mean. And they want to know what percentage is below 25. So we definitely need to go to the calculator and we need to establish some kind of beginning and end, right? So this is going to be the lower limit that I'm going to enter. I'm going to use a very small number, which is minus 10. Actually, great. We can just put any number that we want. I was just going to put a, very small number, minus 0.0000, whatever you want to, right? Very small number, million. The upper limit will be 25,000, right? Because the low, we don't know where this stops. Lower is going to be very low. We want to make sure that we include as much material as we can there. The mean, or mu, is going to be 34,569, and the standard deviation will be 8,256. So let's bring the calculator and let's put that information there. So let's go to menu, let's go to number 2, and we're going to go to distribution, F6, F5, sorry. Okay. Oh, did I press the wrong one? I put binomials, sorry. It's normal, sorry, normal. And we have n F2, and now the lower, it's very small number, minus, right, you can put just any number you want there. That's a nice number there. Minus 25,000, minus 20, no, it's not minus 25, just 25,000, sorry. 25,000 That's 25,000. The standard deviation, because these are not z values, this is real values. They're asking me for the standard deviation, which is 8,256, and mu was 34,569. And it gives me a p-value of 0.123. It's 123. So let's write it here. 123, 123. But this is percentage. They want the answer in percentage. So that would be 0.123 times 100. That gives me 12.3%. So yeah, what percentage of families? Okay, because we don't have a sample, we don't divide this by the square root of n. If we had a sample, then we have to divide by square root of n, but we don't have a sample. We don't have it, so we don't use it, right? That's why we only use the standard deviation as they give it to me. How long would I stay live? I don't know. How many questions have I not answered yet? Let me see. I think I didn't answer 34. I didn't answer 23, 22, and 17. Then I think all of the other questions I answer. Right? Yeah, I answer all the questions. I have all the questions already online. The only questions that I have not done yet is the ones that I mentioned before, like 17, 18, 22, 23, and 34. Only 3 questions I haven't done. So if there are no more questions, I'm not going to continue on live, right? So I'm asking anyone who has a question with any questions that I have not done yet. Okay, remember, you can just pick any value that you want from any video, and you can see which one I have not done yet, or I have done. All questions are online except the ones that I have now. That when I'm done, I'm gonna ask you. I don't remember which ones I did, so at the end we'll kind of look at the questions that I did, so I can put the right label, right? All right, so let's see. I don't know which ones I did this time, so you help me later. Question 34, somebody asked me. Okay, question 34 is right there. The advantage of this is that you have the data, so this is going to change because of that a little bit. Okay, a report. Hold on a second. Let me make sure that I'm doing the right. Okay, a report by Gallup Post states that on average, a woman visits her physician 5.8 times a year. This is in the hypothesis testing. So to make things a little shorter, age of 0 is an average. A woman visits her physician 5.8. So mu is always in age 0. We always use the symbol of equal. It's going to be 5.8 times a year. In a random sample of 90, so this is the sample now. Sample is a 20. And if you can see, these are the 20 here. The number of dots is obtained as follows. And now check yourself. The sample mean is 3.85, and the standard deviation is about, the standard deviation will be for the sample, and the standard deviation is 2.52. How do you check yourself? Well, you can just put those numbers in the calculator the way that they are there. So let's put the numbers in the calculator, which, let's go over here. Let me put this. Ah, shoots. I hate that. Sorry. Okay, so we're gonna go ahead. We need a list to put all of them, and we're gonna put it right the way it is. 3, right? I can't do it that way. 3, enter. 2, enter. 1, 3, 7, 2, 9, 4, 6, 6. You can also make frequency tables here, so you don't have to keep adding this, putting the same numbers over and over again. But you know what? I did it already. Okay, so let's do a calculation of that. Calculation. I'm going to check set. I should only have list 1 because I'm not using list 2, and frequency should be 1, and everything should be the way that I have it here. I'm going to exit. I'm going to go 1 variable, and the mean is 3.85, which is exactly what they give me here, 3.85, and the standard deviation for the sample is 2.52. This is in my calculator. The n-1, it's 2.52 approximately, yeah. So for you, it will be the same thing, right? It has a different symbol, I think it has an S. So we check that this is okay. All right, we check. It says there, check yourself. At, this is the confidence level, it's 0.01. Can it be concluded? So this is going to be H1. Can it be concluded that the actual average number of doctor visits is less than 5.8? I like that because we haven't done this type of test. This is a one-tail test. And if you look at that way, it's pointing to the left. So it will be here. How do you know it's pointing? Remember I told you to make like a little line there, and this is like an arrow, and it's pointing to the left. Okay, let me erase that arrow because I don't want you to get confused. It's going to be a one-tail test, and it's a left one. Okay, so can it be concluded? Now, you can use the 3 methods here that we have used to do this. We can certainly try to find, this is going to be a t-test, right? T-test. Why? Because you don't have the standard deviation. Don't have the standard deviation of the population. You have the standard deviation of the sample. And because even though it doesn't say there, there is a keyword here, Gallup poll. Gallup poll means it's a company, it's an actual company. That if you see the word Gallup poll, you don't have to, this is like saying normal distribution, because these are people who do their experiments or collect their data professionally. That's what they do. So they will have a proven that this is somehow normal distribution by using either a population that is normally distributed, or because they already have done the central limit theorem, and they have proved that if you do many times, you will create normalcy. Okay, so we are going to use the same method if you want to. We're going to use the interval method, right? Confidence interval. I'm going to try to write small so we can fit everything. This is the confidence interval. Okay. The confidence interval here, we have x, it's already had, so we like to find e, right? E is t alpha divided by 2 times the standard deviation divided by the square root of n. So this will give me, I need this t, which you're gonna have to get it from me again, is 2.52 divided by the square root of 20. This e is based on this value, right? So if you do this, okay, you're gonna go into the calculator, into the t inverse function, and you are going to tell me that the area that you're going to, it's only on one side, and the area is 0.01. This is 0.01, and this is the area. It's not divided into two because this is only one tail, so it only has 0.01, 0.01, and I need to know that t value. So if you can tell me what number this one is, thank you. You're gonna have to go into the calculator and give me that value. Let me see if anybody is there to give me the value, right? How do you get it? I kind of tell you a little bit. You're gonna go to 2 and then let's exit here, and you're gonna go to distribution and you're gonna go to t, but I don't have the third choice here for my calculator, so I need someone who's able to get it. It's gonna ask you for the area, and it's gonna ask you, I believe, for the df, which in this case df is 19, and I need this value. The df is 20 minus 1, correct? That is correct. So I need this value, which is called t critical, right? Remember, we mentioned that before. So it's 2.53. It is correct. Actually, I think they use 2.53. They use 4 decimals in the back of the exam to 95. Okay, times that, and tell me if you multiply that. Very good, that's Gary and Ponte, but I think they use 4. I try to use as many decimals as possible now, so I get the best answer. But I'm not going to be that picky in the final exam, you know. Whatever, 2.53 will be fine. So let's go to menu 1. Let's see if you can do that. 2.53. For the now, I'm going to use the entire decimal that they give me in the back. 2.52 divided by the square root of 20, close that, and that's going to give me 1.43, which is the error. 1.4301, 1.4301, right? Okay, so now I'm going to put it over here. X bar, according to this, is 3.85. This is given, 3.85 minus 1.43. I'm going to just use 1.43 because I don't have space. And this is going to be 3. This is given, again, this is given here. 3.85 plus 1.43. Okay. You don't have to use 4 decimal. I mean, it's always good. The more decimals you use, the better it is. But it's not a. The rule is you should always use 2 more decimals that they gave you. I think this probably has 2 decimals, 3.85, 2 point. So I use 2 more. I'm going to put that into a variable x. That's how you save all of this, variable x, in the calculator. So now it's going to be 3.85 minus x because I saved it. That arrow is to save the variable. And it's 2.42. Let's say 2.42, 2.42, right? less than the, I'm approximating, I'm being very bad, I'm approximating because of time here. We don't want to be here the whole night. And the other one would be 3.85 plus x, which remember x still has the value that I saved, and that will give me 5.28, 5.28. And now let's check if mu is 5.8. Is 5.8 inside? Is 5.8, which is the one that they gave me at the beginning, inside of the interval? And the answer is no. So because if it's not inside, 5.8 is bigger than that and bigger than that. So the conclusion is we reject H0. In other words, it's not the mean is not 5.8. That's basically what we're saying. We don't have enough evidence to prove that it's 5.8 based on the information that we have here. That is the confidence interval method. Let's try a different method, right? Let's try the traditional method. Traditional method. Remember, the traditional method compares the value that is given to me against the value based on the information that that I got from the sample. So I have the sample information worked by hand, and the other one is the information that I have from the test critical, T critical, which I already know, right? T critical, you gave it to me at 2.53. So let's see. Now, because this is one tail, how do I know? From the beginning, it's right. It's only one side. If this is the left side, it's going to be negative 2.5395. Now I'm going to work this by hand, and I'm going to determine if it is inside or outside. So this is okay, and this is not okay. Right? Usual, not usually. That's how we used to say before. Now, the T, this is called the T test. Okay, so how do we get the test statistics, right? The test statistic is gotten by x bar minus mu divided by s over the square root of n. So we're going to get this number. X bar is given to us 3.85. Mu was given to us as 5.8. So 5.8 divided by the square root of, I'm sorry, 2.52 divided by the square root of 2.52. No, sorry, and 20. I'm getting tired now. So the test statistic, which is only used by hand, anybody? Sorry, Omar, we didn't divide alpha is not divided by 2 in this case because it's one test, one tail. You remember here we have one, this, if it's not equal to, then it's two tests, then you divide by 2. But if it's less than or greater than, you don't divide by 2 because it's only one tail. So I was hoping somebody was going to do that for me, but I guess no. All right. Let's try to erase all of that and do that. 3.85. I should put it in parentheses. Parentheses 3.85 minus 5.8 divided by parentheses 2.52 divided by the square root of 20. Okay, and that's going to give me negative 0.46. So it's going to give me negative 3.46. So now let's bring these two together, right? The one that determines the okay or not okay is negative 2.5395, and that's not, that's okay. This is okay, and this is not. And the number that we got by hand, this number is here, is in the not okay area. So again, we reject h of 0. And I think it's a good idea. Right. Yeah, we did it again, but we're doing it with a different method. There are three methods. This is method number 1, confidence interval. Method number 1 is second method is called traditional method, and the third method is called the p-value. Okay, the p-value. It's interesting to do the p-value on this one. The p-value here. Oops. Sorry. The p-value here is interesting because it's only one side based on the data that we have. It's only one side, right? And the value that we use is this negative 3.46 because this is the sample. So we need to find out what is the area here. What is the area so that we can compare this area, which is called the p-value area. We need to compare the p-value versus the alpha, but alpha in this particular case is not divided by 2. Alpha in this case is just, what was the alpha value? 0.01. It's 0.01. And now we need to get this p-value to compare whether it's greater or not. All right, so let's go to the calculator. All right, and we are going to go menu and 2, and we're going to select distribution. We're going to go to t-value. We're going to go to the second one because we have a lower limit. We can still use minus because this is very low. And the upper would be minus 3.46. And the df, this was how many? I forgot how many. What was the end value for this? It was a 20. 20. So this is going to be 19. And the p-value is here, 1.31 to the negative 3. So this area here is 1.31 times 10 to the negative 3, right? So, okay, there are more values here, but this is, you're going to move this 3 times. So it's going to be 1, 2, so it's 1, 2, and 3. So it's going to be 0.001, and we're going to compare it to 0.001. Now, we don't need to divide this. This is the one that we don't touch. This is the way that is given to us. And this one is the one that we either divide by 2 or add by 2. Here is just one area, so we don't have to add 2 of them. It's just one area. And we realize that this is less than that. So again, we reject H0. The only way not to reject it if it was greater than, but it's less than. You can use any of these three methods, the p-value, the traditional method, or the confidence interval method. It all depends on what they ask you, but you should be prepared to, if they ask you the traditional method, then you need to get this value and this value, the critical value, and this is by hand, always by hand. If they ask you for the even if you use z values, this is also by hand, and this is not by hand. This is done by the calculator. And if you use the z values, remember in z values or z values, this is always going to be 1, and the standard deviation is going to be 1, and mu is going to be 0. If you're using z values, when you use the critical, when you find this number. In the t critical, you don't need this too, because they don't ask you for it. And if they ask you for the p-value, you have to be able to get this number, which you got it by hand, remember, and then you find the area using the calculator and compare. Okay, yes, that is correct. That is correct, Marianne. If it's in the other side of negative 2.53, we're not gonna reject. Okay, I don't know. I think we did almost all the questions. Okay, any other ones? Oh, 0.01. This value is given. If you go to the top, right? If you go to the top and you look at this, you see, it says that, you see that? It's here. It's the problem says that the alpha is 0.01. And because it's only one tail, we don't divide by 2. We only use exactly what it is. But when you compare, you use exactly this number, 0.01. All right? It's only on one side, so we don't need to. It has to be exactly as they gave it to you. So that's where it came from. This is where this came from. Okay. All right. Are we okay, ladies and gentlemen? We still have a good number of people watching still. It's almost more than half of the classes here. Do we have question number 27? Let's see if we have question number 27. If I don't have it here, what question was this? 34. Let's do it. This is 31. This is 24. 23. 22. Those are the only two questions of 17 also. There's only 3 questions that we haven't done, and if we look at the ones that are online, 27. Let's see, 27 is let's see if we can find it here. 27, 13, 21, 11, and 12, 8, 9, 10, 3, 4, 5, 7 for this one. That's for another class. Let's see, 25, 26, 26, let me see, 27. If you look at this particular video here, it says the final review has question 27, 28, and 29. It's there. So you're going to have to look for it because it's already there, and it's crazy to do it again. All right, so that one is done. I think you guys have not watched all of them. Mariam, I'm almost done. Don't worry about it. Okay. I think I'm done. unless there's any other question that you want to see, I think I'm pretty much done. I just want to ask you for a quick question. I need it. Actually, I have a pen here. What questions did I do tonight? Can anybody help me so that I can write definitely 34, right? I think I did 34 tonight. Maybe if you can tell me what other ones. I did 31, I think. I did 31. I did 24. Okay, I don't know which one. I didn't do those three. Did I do this tonight? No. This I didn't do tonight. I did this tonight? No. No. I did this one tonight, which is, I believe, 16. Yeah, 16. So I did 31, yes. 16, yes. 24, yes. And 34, which I just did. All right, so I can label them correctly when I go, when I do it. All right. Any other question, my friends? Or can we say that we did everything tonight? I'm gonna wait for a few minutes. So if you have any question, this is the time to ask the questions. Okay. I'm hanging out here for a little bit. Okay. I think we're done. I want to thank everybody. Go to, try to, go to sleep early and maybe spend another time, an hour or so, doing some stuff. But other than that, I'm gonna stop the transmission now. We were here for like almost an hour and a half. So, what is 6F means? I didn't answer F. Oh, sorry. Did I not answer F? Let's see. What question is 34? Did you have another one? I didn't answer 6F. I don't understand what 6F means. This 34 had a F question? No. Which one was it? You didn't answer F. What is F? Question 6. Really? Let me see if it's question 6 somewhere there. Okay, this is 13, that's 18, that's 21, that's 11 and 12, 8, 9, and 10, 2, 3, 4, 5, 7. That's 14, 30, 33, 1, 30, 25, 26, 19, 20. That's 27, 28. You may be right. I didn't do 6. Okay. Guess we can do 6. I don't know if I have it here. Do I have it here? Let's see. Okay. Which is 10, 9, 8, 7, 5. Oh, okay. So I need to go online because I don't have it here. Okay. So let's go online. Let's go to okay, that's different. Let's go to MAT-120. Let's go to exams, final exam review. Is 6 there? Okay, I don't know what that means. 6. Ooh, I passed 6 already. Okay. All right, so let's copy that, right, and put it into a new page. Now we're gonna change the color of that very soon. We're gonna also has the other section. I think I answered this question. I know I did, but I will repeat it again, I guess, because it's we are going to, basically you can do this in the calculator. Okay, so let's change the background to black. I like this one better. It's easy on the eyes. Okay, so let's go back to here. Okay, but not part F. Okay, 6, part F. Okay. She said, I did 6 or not did 6. I don't get it. I'm question 6. Um, is there any particular part F1, I guess, question 6. Okay, first of all, you got to put this in. If you put this in the calculator, you're going to find the mean, the Q1, Q2 maximum for the data. Construct for this regulation, which measure for the center is large, the median. Okay, so we can put this in the calculator, I guess, and well, I'm going to do it a little fast, so, keep up with me. Number 2, I'm going to put the numbers there. 31, 33, 35, 36, 40, 40, another 40, 41, 43, 45, 47, 48. This is basically a calculated problem. 51, 51, 52, 55, 56, 59, 70, 71, 74, 76, 78, 84, 87, 87, 90, and 93. Okay, so we are going to go to distribution. Oh, sorry, exit. We're going to go to calculations. I think I only have one, only one column. One variable is there. And we have the mean. We have a lot of information here, so we can write it down. Hold on, where is the pen? We have the mean is 58.26. Let's go back to the calculator, see that we have the 5 points, right? Which is the minimum. The 5 point is 1, 2, 3, 4, 5. Minimum Q1, median, which is also Q2, Q3, and the maximum. So we have the minimum value X is equal to 31. The Q1 is equal to 52. Q2 is equal to 52. Q3, okay, I need to see it again. Q3 is 76. Q3 is 76, and the maximum value is equal to, the maximum value has to be equal to, what is it? 93, right? 93. So I'm going to use, this is called a 5-point summary. 5-point summary. And I don't have a ruler, so, and because of time, I'm going to do it here. The smallest number is 31, and the highest number is 33. So maybe I go 30. Oops, sorry, I forgot that I don't have that. I know because I know I forgot part F, but I guess I gotta do all of that because I don't remember what I did. So if I use, sorry, let me use 30. Let me see, every 30, 40, 50. I'm just using an arbitrary scale, 70, 80, 90, 100. So let's use This is 31, so I'm guessing I'm gonna read here 52. So I'm guessing the location of these things. 52 Q1. Did I make a mistake now? Let me just double check the Q1. So this is probably a mistake. Minimum Q1 is minimum is 31. Q1 is 41, 52, 76, 93. So Q1 is 41. Sorry. So this is wrong. This is 41. So we forgot to put that one as 41. I'm guessing that's going to be somewhere there. 52 is there. 76 is there. And 93 is probably there. All right. So from Q1 to Q3, we're going to do that. And then we're going to extend like that. So that answers A. We answer B. For this, sorry, I got lost a little bit. For this frequency distribution, which measure of the center is larger, the median or the mean? The median, oops, why I keep forgetting that I have that. The median is the same as Q2 and the mean. So we got that from the calculator. The median is 52 and the mean is 58. So for this frequency, which measure of that? The mean. The mean is greater than the median. Okay. So we did that. You don't have to calculate the mean to answer. Okay, well, there you go. Anyway, we did calculate it. Circle the correct choice and fill in the blanks for D. The median mean better describe the center of this data set because the shape of the distribution is. Now, notice that this is a large, this leg here is kind of long, longer than this one. This is a short leg. And because this is long on the right side, this is skew to the right. So whenever you have skew to the right or the left, it is big, you know, this is a long one. That means that most likely there are numbers that are outliers. And whenever you have outliers, the best choice is the median, right? And because the set of shape, if you can, is skew to the right. And I show you why, because this leg is longer. Okay, complete the following sentence. The test scores does not exceed for 75. Okay, 75 is Q3. This is 75% of the data. It doesn't go beyond 76. So it doesn't go the highest value for Q3. This is basically saying Q3. The test score does not exceed. It's not more than 75 for Q3. Yeah, it's not more than that. It's 76. Okay, F. Complete the following sentence. The test score does it at least in this class. The test score is at least for 75%. What is the test score of the people? What is the test score is at least for 75? Now this it says that is the test score does not exceed 76. I believe that this is a mistake here on this question. I'm sorry. This is a problem from The people who write this is 25%. It's not 75. This is a mistake that they made. So this is basically saying Q1. Q1 is 41. Okay, so this is a mistake that they have. So that mistake is not going to happen in the final test. That's why it seemed like a mistake there, but it's your mistake. You couldn't understand it. It's not your mistake. It's their mistake. I gotta send this test tomorrow so that they review it. Okay, I think we have also done most of the exam. Take a look at the exam, correct the mistakes that they themselves made, and let me know. Okay. Okay. I think Mrs. Gary is still there, so that means Starbucks is still open. All right. I think we're done. Let me know, please, because I'm about to close now. No problem. Let me know if I think we have done a remarkable job here. You guys did a good job. Hopefully tomorrow this is pay off. Will pay off. This video will be posted. Yes, it will be posted. Farah is there? I didn't know. Yeah, this video will be posted. As soon as I finish with this transmission now, I will post it. Okay, so I'm gonna go to close the session. Okay, yeah, session is down here. I'm gonna stop streaming. And thank you so much and have a good night. Sleep, study, be ready for tomorrow.